Page 240, lesson 4.2 is on patterns and linear functions. A little bit of the stuff at the beginning we've already talked about. Some of the vocabulary here, so I'm not going to get into that too much. Last lesson we talked about dependent variables, independent variables, inputs and outputs. One thing we could mention at the beginning here, it says identify quantities in the picture that vary in response to other quantities and describe each relationship. So there's a lot of different things that are going to be changing over time here. One, we could say the temperature, we could say the time on the clock literally. We could say the distance traveled by the joggers, the height of the shadows, the water that's come out of the fire hydrant, the time left on the parking meter, the speed that the car's going, how many people are in the area. Lots of different variables we could talk about, lots of things that are going to be changing over time here. So if we look at this, again, those vocabulary words we already talked about last lesson. So problem 1, in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. And this carries over to the next page. So if we just try and look at both of these at the same time here, the first thing they did is they made a table, and they defined their variables here. Instead of equals, they should really say represent. So you'd say let X represent the number of rectangles, let Y represent the perimeter of the figure. So if you look, the first one has one rectangle, and the perimeter, remember, goes all the way around. So the perimeter all the way around that would be 14. So we could have 1, 14. If you wanted to, your table could just be like this, 1, 14, okay? This is not a bad idea though, having a spot to work it out. If you don't have a spot to work it out on your table, you need to be working it out to the side. Perimeter only goes around the outside, so if we add another rectangle, our new perimeter is 16. Really the only thing that changed is we have a little bit more on both of these ends. 3 is 18, 4 is 20, and so on, okay? And so what we can do is we can notice what's happening with our perimeter as we increase a rectangle. So the pattern is that we're adding 2 to our perimeter every time we add a rectangle, okay? So adding 2, that's going to help us to come up with an equation for this relationship, because that's like our rate of change. We're going up 2 for our perimeter for every 1 rectangle. So that's going to be our slope. So our equation we're going to look at, we talked about last year proportional relationships. So proportional relationships, we talked about y equals kx or y equals mx, okay? So our equation is going to be y equals 2x. That's a starting point. We're going to have to adjust that a little bit. So the deal is we have to look at what we need to add or subtract to that to get this to work. So if I put a 1 in place of the x right now, what would I get? Right, I would get 2. So what I want to happen, instead of getting 2, I want to get 14. So what change would I need to make for that to go from a 2 to a 14? Right, we would have to add 12. And so what that means on my equation, I'm just going to adjust it by putting a plus 12. And then what we can do is double check that to see if it works for the other ones. So if I put in a 2, do I get 16? Well, let's see. 2 times 2 is 4, plus 12 is 16. That works. And we could try it with the other ones, and that will work for all of them. This is our equation. So the key to this, first of all, is seeing what's the pattern of what they're adding or subtracting every time. That's going to be your slope. That's going to be your coefficient of x here. And then it's just a matter of how do I need to adjust that. Some cases you might not have to adjust it at all. In this case, adding 12 was what we needed to do in order to make this work with our numbers. I briefly mentioned this a minute ago. On these that we talked about last year, K was called the constant of proportionality, and the M was a letter that represented slope. And we'll be getting into more of this one, especially the y equals mx, as we go along in this chapter. So if we look at the got it 1 in the diagram below, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using the table, words, an equation, and a graph. Oh, going back to that last one, I didn't look at everything that we were supposed to do there. We did the equation. The words, they just said you could multiply the number of rectangles by 2 and then add 12. Okay, just basically taking our equation and writing it in word form. And then the graph, they just graphed those out, just graphed those ordered pairs. And that should be it, I think. Because the table we already did. Okay, so that's kind of the order I like to do these in. You don't have to necessarily do it that way, but I like to have a table first and then come up with my equation and then do the other stuff. Okay, so in this case, our x is going to be our triangles, and our y is going to be our perimeter. So for one triangle, if we add those sides together, our perimeter would be 10. For two triangles, if you look at that, if you add those numbers together, two triangles, the perimeter is 14. Three triangles has a perimeter of 18. And four triangles has a perimeter of 22. Okay, so this would be our table. Then what we're going to do is we're going to look at that table. We're going to try to find a pattern of what's happening here. I mentioned that basically we just look at a pattern, what they're adding or subtracting. We really also need to look at what's happening with our x value. If you guys remember, slope is a change in y over change in x. So that last example, we were able to just get by looking at the y's because the x's were only going up by ones. But always look at that, the x part also, because if they're not going by ones, that's going to affect what that slope is, what that coefficient of x is going to be on your equation. So our y values, our perimeter, each time we are adding 4. And just to check on the triangles, each time we are adding 1. Okay, so our slope, change in y over change in x, is 4 over 1. So 4 over 1, which is the same as 4. So what that tells me, my equation is going to start out as y equals 4x, and then we'll see whether we need to adjust that or not. So we think about putting a 1 in there. We put a 1 in place of the x. We would get 4 if we put a 1 in place of the x. 4 times 1 is 4. We want to get 10. It's over in our table over here. Okay? So we're getting 4, we want to get 10, so getting from 4 to 10, we would have to add 6. So this should be our equation. It's always a good idea to check it. So if you look at your next point, if you put a 2 in, we want to get 14. So 4 times 2 is 8. All right, I wrote the wrong number here. 4 times 2 is 8, and then 8 plus 6 is 14. So that works. You can check it with the other ones also, and they will work as well. So that would be our equation. We've done our table, and then the other part would just be the graphing that. Graphing, if you did the graphing, you would want to make sure that you label your graph. So this could be our number of triangles, and this could be our perimeter. So the triangles, you could just go by ones if you want. Since they're adding 4 every time, you could actually do kind of a sneaky deal here, I guess. You could do a break on your y-axis, and then you could start at 10 and go by 4s. Okay, so one triangle had 10, 2 had 14, 3 had 18, and 4 had 22. And this is easier done on graph paper than like I'm doing it here. But anyway, those points should line up with each other. In this case, we wouldn't connect the points because we're not going to have like 1.5 triangles or anything like that. Just the actual, whole number of triangles would make sense for our graph in this case. And then for the words, we could just say something like the perimeter is 4 times the number of triangles plus 6. So the bottom of the page talks about function. So it says in problem 1, the perimeter is a function of the number of rectangles. So a function is a relationship that pairs each input value with exactly one output value. Remember, our input values were our x values, and our output values were our y values. So each x value gets paired with exactly one y value. One way of thinking about this idea of a function is this function machine here. So this function machine, we have an input, or our x value, which is the independent variable, gets put into this machine, and then something happens with it. Okay, like on that last one, we multiplied by 4 and we added 6. And then out of that, we get our output, or our y value. An analogy I use with these to help you understand the idea of a function is if you're baking something. So let's say that we are baking cookies. So we get our ingredients together, we mix it up, we put it in the oven, and when we get done, we know what's going to be coming out of the oven is going to be cookies. Okay? Depending how long we left them in, they could be more burnt or not burnt, or they could not be done all the way, whatever, but they're going to be cookies. Okay? That's the idea of what they're saying here. Each input value has exactly one output value. If I have one set of ingredients that I'm using, one recipe that I'm using, I'm going to get one certain thing when the oven, when I open the oven. Okay? It's not a matter of it gets done and I open it up and it's going to be a surprise. Is it going to be cookies or is it going to be meatloaf? Okay? That doesn't make sense. If we have certain ingredients, we're only going to get one thing out of the oven whenever it's done. Okay, so that's the idea of the function. Each x value has just one y value. So each ingredient has only one food that comes out of the oven at the end. One other thing, a specific type of function we can talk about is a linear function. A linear function is a function whose graph is a non-vertical line. So In the word linear, you see the word line. So linear function is a straight line, except it can't be just vertical. Then it's a linear function. So problem 2, the table shows the relationship between the number of photos X you take and the amount of memory Y in megabytes left on your camera's memory chip. Is the relationship a linear function? Describe the relationship using words, an equation, and a graph. Okay, so what we're going to do is, they've already made the table for us. We're going to try to look for a pattern. So pattern is with our Y values, they're subtracting 3 every time. And we always want to look at our X's also. With the X's, each time they are adding 1. So if we think about this, for our slope is change in Y over change in X. We're subtracting 3 for our Y values, and we're going up 1 for our X values. So that slope would be -3. So first of all, notice the pattern is consistent. It's always down 3 over 1, down 3 over 1, or subtracting 3 for the Y, adding 1 for the X. So this is a linear function. And then our equation, we would start with Y equals -3X. And I think we're going to have to adjust that one a little bit. This one's got an X value of 0. That makes my job even easier. So I can think about putting a 0 in for X. So -3 times 0 is 0. We didn't want 0, we actually wanted 512. How do we get that? By adding 512. So this would be the equation that would work for this problem. The book, if you notice down here, they have the equation written differently. It's still the same thing. Okay, if you add the opposite, if you then change the order of these, you'll get the same thing. In words, they did this. The amount of memory left is 512 minus 3 times the number of photos taken. Okay, so if you like the format of their equation better, to think about we're starting with 512 megabytes and we're subtracting 3 for every time, that's fine. You can do it in that order. And then the graph they did over here. Notice the graph, they did a break on the y-axis because I don't want to go up by ones until I get up to 500 something. My paper would have to be pretty big, or my lines would have to be pretty close together. So if you look at the guide at 2, is the relationship in the table below a linear function? Describe the relationship using words, an equation, and a graph. Okay, so first of all, it has to be a linear function in order for us to come up with an equation and everything. So let's look for a pattern here again. Output is the Y, input is the X. Look at the Y's. So the Y's are adding 2 every time. X's are going up by 1 every time. So our slope of our line is going up 2 over 1. So our slope is 2. So our equation, we would start with Y equals 2X, and then we'll see about adjusting that. So if we put in a 0 for X, 2 times 0 is 0. We want to get 8, so we would have to add 8. That would be our adjustment. So that would be our equation. So the pattern was consistent again, so it is, yes, we would say it is a linear function, first of all. That's our equation. Using words, we could say, multiply the X value times 2 by 2 and add 8 to get your Y value. And then the graph, we could do that. In this case, we're just saying input is our X and output is our Y. And probably could get by without a break there. If you wanted to go by 4s. Since they're going, well, the book's saying go by 4s. I would just probably do a break again and just start at 8 and then just go by 2s. Okay, so we'd start at 0, 8 and then go up from there. You guys can do the graph part. And again, it's a straight line, so it is a linear function. Part B, does the set of ordered pairs there represent a linear function, and explain. So this is not a linear function. One thing would be that we could graph these points and see what they look like. And kind of our main problem here on this one is that we have cookies and meatloaf here for the same ingredients. We have a 1, 4, and we have a 1, 8. Same input, we got 2 different outputs. That can't happen if it's a function. If it's a function, for every input we only have 1 output. For every x value we can only have 1 y value. So that's the reason why this one is not going to be a function. So this gives you an idea of how to work with patterns and linear equations.